In this video, I introduce fine-tuning language models from human preferences. Reinforcement learning is applied to solve complex tasks defined by human judgments, where a good or bad result is only judged by humans. Human judgments are used to train a real-world model and then optimize the real-world model using reinforcement learning to obtain the optimal policy. The KL constraint prevents the policy shifting too far from the obtained real-world model. The pre-trained large language models are used to initialize the real-world model and the policy because they have the common sense and natural language. This model flow work, which is interleaved between real-world model training and policy training. First, the initial policy is used to generate input to the real-world model, and human labels are used to train the real-world model with supervised learning. The real-world model is used to train policy, and the improved policy is used to improve the real-world model. Given a vocabulary, a language model role defines a probability distribution over sequences of tokens via this formulation and shown in this figure, which maps a distribution D over input space X to outer space Y. For example, X is an article and Y is a summary of X. A policy pi is initialized to raw, and then policy pi is fine-tuned to perform a task set using reinforcement learning. If the task is defined as a reward function R, reinforcement learning maximizes the expected reward defined as here. Now, the goal is to perform tasks defined by human judgments, namely the rewards need to alignment with human preferences. To this end, human labels are first used to train a real-world model with supervised learning. Then the trained real-world model is optimized by using reinforcement learning. And finally, the optimized policy is applied to generate a summary with human preferences for a given article. Human picks one value, YB, from Y0 to Y3 as the best response to a given input X. Suppose that S is a set of tuples where B is a 1, 2, 3, or 0. The real-world model R is trained using the expected loss with supervised learning, as shown here, and in this figure. Since the real-world model needs to understand the language, it's initialized by language model policy role and replaces the final output layer of the language model with a random linear function, as shown here. To keep the scale of the real-world model consistent across training, the real-world is normalized to its mean 0 and variance 1 for X and Y. The trained real-world model R is optimized by fine-tuning policy pi, namely reinforcement learning is performed on the modified real-world R, as shown here. For more details, please check with these references. Thank you. Bye.